Welcome back for some more GCSE mathematics. This is the hardest question on the 2019 paper 2 foundation, question 20. It's an inequalities question. So the first part, solve 14n is greater than 11n plus 6. So as usual, we treat an inequality in the same way that we do an equation, except for the equal sign in the middle there's going to be an inequality symbol, but we treat it as the same as in we use inverse operations, i.e. the balance method. Hopefully that's what you guys have been taught and this makes sense. So here we notice we've got n on both sides of the inequality. So the first step here would be to analyze this is the method I use anyway, which side has got the least amount of the unknown n, and that will be 11 here on the right. So what I would advocate first of all is subtracting 11n from both sides, which has the effect of removing n from the right hand side and leaving us simply with 6. So 14n subtract 11n leaves us with 3n. 3n is greater than 6. The inverse of multiplying by 3 is to divide by 3. So we divide both sides of this inequality by 3. And that will give us n is greater than 6 divided by 3, which is 2. So your solution is that n can be anything greater than 2. Make sure we get that on the answer line. Okay. Second part, B. On the number line below, show the set of values of x for which, now this is what we call a compound inequality. There's two parts to this. You got -2 less than x plus 3, but you've also got x plus 3 less than or equal to 4. So what we do, again using the balance method, whatever we do to one side we do the same to the other, but of course with a compound inequality, which is made up of these two parts, we have essentially three sides to be dealing with. So what the aim of this is to get x on its own. Now to go from x plus 3 to x, we are subtracting 3. So therefore we need to subtract 3 from the right hand side and the left hand side as well. So subtract 3 from all three parts. -2 subtract 3, be very careful. We're at -2. Taking away 3 will go more negative, i.e. -5. Copy down the inequality symbol, or symbols. And then on the right hand side, 4 subtract 3 is going to be 1. So now we need to show that on the number line below. So we have the interval. X can be between -5, so I'm going to put a circle above the -5, up to and including 1, positive 1, so a circle above the positive 1. So x is in between those two values. Now, x cannot be equal to -5, it must be effectively, -5 is less than x, so x is greater than -5. So we do not shade that in, that the circle above the -5. However, on the upper limit of positive 1, x can be equal to positive 1, so we're going to shade that in. Okay? And we are allowed to be every value in between those two limits. So, that's your solution, and that is your solution on the number line. Hope that makes sense.